Hey everybody, Mr. Piercy here, and we're going to be looking at some word problems associated with trigonometry, very typical type of word problems that you might expect to see. But one of the first things that we're going to talk about is something known as angle of elevation and angle of depression. They're two vocabulary terms that are typically associated with a trigonometry course, and they can be really easy to understand, but they can also be very easy to mix up and confuse. So here's some notes that I want you guys to look at for our angle of elevation and angle of depression, because they do kind of get put into different word problems that you'll be trying to figure out. So looking here in the diagram, we see a person staring up at a balloon, and it's a very typical kind of thing where somebody's looking up at something or looking down at something. And we see the terms angle of elevation and angle of depression. Well, an angle of elevation and an angle of depression are very similar to each other. They're both going to be a horizontal line. However, the angle of elevation is going to be above the horizontal line, where the angle of depression is below the horizontal line. Pardon me. Excuse me, got something in my throat here. So we have two horizontal lines that we see in this figure. We have somebody that's looking from the ground up at the balloon, and maybe somebody that's up in the balloon looking down at the person on the ground, creating both of our angles of elevation and depression. So the horizontal lines in this case are parallel to each other, because every horizontal line is parallel to every other horizontal line. So what that means is that the angles of elevation and depression are congruent to each other. And this goes back way back to when we were talking about alternate interior angles. I can kind of put some lines there if I wanted to, and kind of make it a rectangle. And so we know that this line here is parallel to this line here. So this line of sight, that's our transversal line, creating our alternate interior angles. So if we draw vertical lines in, we can make some triangles. So here we have a right angle, here we have a right angle. And you can see, depending on where you're standing, if you're in the balloon, your triangle is here. And if you're on the ground, the triangle that you would be looking at would be right there. So just make sure you understand the difference. Angle of elevation and angle of depression both come from a horizontal line. However, the angle of elevation, you're looking up, and angle of depression, you're looking down. So here we just have a diagram of this person hiking in the mountain somewhere, and we want to be able to identify the angles that are made. Are they angles of elevation or angles of depression? So we have a bunch of horizontal lines that we see in the diagram, and anything that's below a horizontal line is an angle of depression. Everything that's above the horizontal line is an angle of elevation. So angle 1 is below the horizontal line, so it has to be an angle of depression. Same thing with angle 3. Whereas angle 2 and angle 4 are both above the horizontal line, so those would be considered an angle of elevation. So this is just a way of, can you identify uh, an angle of elevation or depression based on something that's drawn for you. Now things aren't always going to be drawn for you, but let's go ahead and take a look at a couple of examples here. So in the diagram we have a palm tree casting a shadow that's 18 feet long. So we have the shadow is 18 feet. It also says that the angle of elevation with the sun is 25.7. Well, since the angle of elevation has to be made with a horizontal line going up, then the angle of elevation, 25.7, is going to be right there along where the sand is. And we want to know how tall is the palm tree. So that's a pretty easy operation to do. Based on where my angle is, x, this is the side opposite of the angle, and we know the side adjacent to the angle. So opposite and adjacent says to use tangent. So I'm going to say tangent of my angle is equal to the opposite side over the adjacent side. And in this case, we'll say tangent of 25.7 is equal to uh, the opposite side, which I called x, and the adjacent side, which is 18. So solving for x, I'm going to get 18 multiplied by the tangent of 25.7 is equal to x. So that means when you type that into your calculator, rounding to the nearest tenth, in this case is what the instructions say to do, rounding to the nearest tenth gives me 8.7 feet for the approximate height of the palm tree. So now this one's a little hard to see on here. The triangle, excuse me, that we're looking at is kind of right here where this is 10.5 degrees as that angle right there. Okay. So the sign on the roadway says the mountain road indicates the road will incline at 10.5 degrees with the ground, which is actually pretty steep when you're talking about trying to drive up a hill. The altitude for a car ascending up the mountain is 3,850 feet. So the altitude going up, altitude has to be a vertical line somewhere. So the altitude in this case is going to be 3,850 feet. And this is going to vary, these types of questions where we're talking about altitude and finding the length of the mountain and road, the mountain here, this is a very easy thing for students to mix up. I cannot tell you how many times I've seen people, flip-flop those where they think the 3850 is the length of the road and the altitude uh, is what we're looking for rather than that's what was given to us. Now it does say find the length of the mountain road in miles. Okay, so now looking at the angle, the side, the 3850, this is the side opposite of the angle. The part that we're looking for is my hypotenuse. Opposite and hypotenuse tell me to use sine. So we have sine of theta is equal to opposite over hypotenuse. So we're going to say sine of 10.5 is equal to the opposite side, 3850 over the hypotenuse, which I called x. So that means x is going to equal 3850 divided by the sine of 10.5. So that gives me x to be approximately, typing into your calculator here, approximately 21126.506 feet. So that's how many feet it is. So we want to know how many miles it is. So there's 5,280 feet per 1 mile. So I'm going to take the 21,126 feet, and I'm going to divide that by 5,280. So that will give me x in miles to be right about, not 4 feet, right about 4 miles, which sounds pretty reasonable for a length that you might be driving. There we go. All right. Now here, these are examples that you might want to go ahead and pause the video and try working them out yourself because they are very similar to the two examples that I just did, meaning that they're kind of giving you a diagram to work with a little bit so that we don't have to figure everything out on your own. And then the last two examples are just examples where the diagram is not given to you and you have to kind of figure out what the diagram would be. So if you want to go ahead and pause the video and work out these 4 examples here, and then when you're done, hit play again, come back and see how I worked them out. All right. So if you hit play, or if you went ahead and worked these out, or if you're just kind of waiting for me to work them out and follow along with me, either way is fine with me. So let's look at example C. The sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. So from the cruiser to the submarine, that's 4,000 feet. And then it says the angle between the waterline and the submarine is 34 degrees. Okay, so I want to take my 4,000 feet and I want to move it. I'm going to say, 4,000 feet. And the angle between the waterline and the submarine, they're saying, is 34 degrees. So how deep is the submarine? So we're looking for the depth here, and I'll call that x. So from my angle, we know the hypotenuse, and the adjacent side is what we're looking for. Adjacent and hypotenuse tell me to use cosine. So I'm going to say cosine of theta is equal to the adjacent side over hypotenuse. Substituting my values, cosine of 34 is x over 4,000. So solving for x, multiplying both sides by 4,000, I'll get 4,000 times cosine of 34 to equal x. And typing that into my calculator is going to give me somewhere, where did I put it? 3,316.2 feet to be the approximate value for x. So it's about 3,300 feet below the surface of the water. Part D, a 20-foot ladder leans against the house, and the base of the ladder is 5 feet from the house. So this is a 20-foot ladder, and it's 5 feet from the house. And it wants to know what's the angle formed by the ladder in the ground. So this is the angle that we're looking for. So that would be considered the angle of elevation because it comes from a horizontal line going up. So from the angle, this is the adjacent side. This is the hypotenuse. So adjacent and hypotenuse again are going to use cosine. So cosine of theta, adjacent over hypotenuse. And we're looking for theta in this case, so that means theta is equal to the inverse cosine of the adjacent side over the hypotenuse. So theta is equal to the inverse cosine of 5 over 20. Type that into your calculator, and you will get an angle of about 75.5 degrees. Part E I really like because it's asking you to perform two operations in order to figure out what you're looking for here. Basically, we have two triangles where we have an angle of elevation to the building of 24 degrees, and we have an angle of elevation to the flagpole of 27 degrees, and we want to know how tall is the flagpole. So we can figure out the height of the building, and we can figure out the height from the ground to the top of the flagpole, and then we can take the difference of those and see what we can get. So it tells you that you're 500 feet away from the building, and so here, this is my opposite side of the angle. This is the adjacent side of the angle. Opposite and adjacent says to tangent. So let's go ahead and find the height of the building. So I'm going to say tangent, opposite over adjacent. So in this case, theta is 24 degrees. So we're going to say opposite, which they called h, over 500. Solving for h, I'm going to get 500 times the tangent of 24 to equal the height. So the height of the building, in this case, when you type that into your calculator, is about 222.6 feet. That's about the height of the building. So now we got to figure out from the ground to the top of the flagpole. Same thing. Tangent is opposite over adjacent. So in this case, theta, the angle of elevation, is 27 degrees. The opposite side is k over the 500 again. So again, multiply both sides by 500, and I will get 500 times the tangent of 27 to be from the ground to the flagpole. And when you type that into your calculator, you're going to get about 254.8 feet to be about the distance from the ground to the flagpole. Well, the question is asking us, well, how tall is the flagpole? So I'm going to say the 254.8 minus the 222.6, and that's going to give me about 32.2 feet for the height of the flagpole, which I don't know, that sounds pretty tall, but I guess if it's putting it up at the top of the building, maybe it needs to be kind of tall. Now the last one here that I really like as far as the examples where they're giving you a diagram, I really like it because this is something that a lot of kids will miss a little detail on. And I want to point out what that is here. So we have a 2-meter television camera at ground level is filming the liftoff of the space shuttle. So from this section right here is 2 meters. All right. The angle of elevation is 32 degrees, and they are 750 meters away from the space shuttle. So from here, what we want to know is find the height of the space shuttle, and I guess instead of looking at the height at the tip of the figure, we're going to kind of look at it as it is from here, from the ground. So we're kind of looking at this triangle like this, but we also have this 2 meters here. And that's the part that a lot of students will kind of forget. So let's go ahead and call this X. And from my angle, this is the opposite side that we're looking for. This is the adjacent side of the angle. So opposite and adjacent is to use tangent. So I'm going to say tangent of theta is equal to opposite over adjacent. So tangent of 32 is equal to X over 750. Solving for X, multiply both sides by 750. Gives me 750 times the tangent of 32. Type that into your calculator and you will get about 468.7 meters to be the approximate height. But it wants to know from the ground. So remember, this triangle that we're forming is 2 meters above the ground. The base of the triangle is 2 meters above the ground. So you have to add, I have to add 2 meters to my calculated value here, and that would give, so that would give me about 470.7 meters for my overall height. Now, personally, some of you may say, well, why won't you do it up here? Well, that's what I would have done it as, but I didn't draw the diagram, so we just do it from the bottom. So the last thing that we're going to be looking at here, these are examples where we don't have a diagram given to us. And these are going to be the kinds of questions that you're going to be doing probably more of, where you have to be able to see, well, if they don't give me the diagram, can I use the information that was given to me to figure it out? So a skateboard ramp at a park, and if you want to, again, go ahead and pause the video and try to work these out. And when you're done, hit play again and see how I did it. Let's go ahead and take a look at these. Skateboard ramp at a park has an inclination of 54 degrees and its base is 12 feet long. What is the length of the ramp? Well, the base is pretty easy. We can say that the base would be the horizontal line, so that would be 12, and this is 54 because it's that would be the inclination, the angle of elevation as it's made with the ground. And we want to know what the length of the ramp. Well, the ramp is the part that you're actually going to be going up and down on, so we'll call that x, the hypotenuse. So from the angle, this is the adjacent side, and this is the hypotenuse. So adjacent and hypotenuse tell me to use cosine again. So I'm going to say cosine of my angle is adjacent over hypotenuse. Cosine of 54 is equal to 12 over x. So that's solving for x will give me x to equal 12 over cosine of 54. And if you type that into your calculator, you're going to get the length of the ramp to approximately be 20.4 feet. Now again, keep in mind we're only rounding to one decimal place here because that was the instructions that we were given. Otherwise, we would be doing it to 3 decimal places for a side and 1 decimal place for an angle. All right, so you're 200 feet away from the river. Rather than walking directly from the river, you walk 400 yards along a straight path to the river's edge. What is the angle between the path and the river? Okay, so we have a river. So here's the river, and here's you. And you are 200 meters or 200 yards away from the river. And instead of walking directly there, you kind of head this way and you walk 400 yards. So we want to know what's the angle between that path, the 400 yards that you walked, and the river's edge. So this is the angle that we're looking for. Now, some of you astute students may recognize that I don't actually have to do trig here because the hypotenuse is twice the length of that leg. So that follows the pattern of a 36 and 90 triangle. So the angle really should be 30 when I work it out, but we are doing trig, so let's go ahead and take a look at it. So from the angle, we are using the hypotenuse, and this is the side opposite of it. Opposite and hypotenuse said use sine. So sine of theta gives me opposite over hypotenuse. So in this case, we're looking for theta, so I'm going to say the inverse sine of the opposite side over the hypotenuse. Substitute my values, and I'm going to get 200 over 400. Type that into your calculator, and you'll get 30 degrees exactly. So the last one here is a really good question. I really like it a lot because it makes you think about, well, how does it look? What is it, what are the angles that you're working with? What does the triangle look like? Water tower is located 325 feet away from a building. So we'll go ahead and say, here's my water tower. Okay, we have a water tower. And let's see, we have a building that's 325 feet away from it. So we have a building that I have no idea how tall to make. So building, building, building. You don't need to go any kind of this detail. This is just how my brain works when I work it out. So we know that this is 325 feet. And then it says there's an angle of elevation to the top of the tower that's 39 degrees and an angle of depression to the bottom of the tower that's 25 degrees. So how tall is the tower? So I'm going to say that there's a person here in this window looking up this way and looking down this way. And so their line of sight is a horizontal line like this. So we have a couple of right triangles here where this angle here is 39 degrees. This angle here is 25 degrees. And we want to know how tall is the tower. So this is still 325. So I will call this x and this y. So the sum of x and y will give me the height of the tower. So give myself a little bit more room to work here. All right. So let's find x. X is the opposite side versus the tangent, or versus the adjacent side, 325. So that's going to give me tangent. So I'm going to say tangent of my angle is opposite over adjacent. So in this case, tangent of 39 is equal to the opposite side, which we don't know, over 325. So that's going to give me 325 times tangent of 39. And so type that into your calculator, and you'll get about 263.2 feet for x. And then we're going to do the same thing. So even though the triangles are reflected across that line, they're not congruent to each other, but they are reflected across it. we're still going to be looking at tangent because the side that I labeled y is still opposite of the angle of 25 degrees. So we're going to say tangent again. In this case, tangent is 25 degrees. So solving for y is going to give me 325 times the tangent of 25. Type that into your calculator and you get about 151.5 feet for y. So the total height is the sum of those two things. And again, I'm using rounded numbers, so this is even going to be more of a rounded number. But it's about 414.7 feet tall for the sum of the two lengths that we got. That's how we're going to be looking to find the using word problems, understanding the, we have to, if a diagram isn't given to us, pay attention to how it's phrased to see, am I looking for an angle or a side, and how do I label the triangle if a triangle is not given to me. Also keep in mind angle of elevation, angle of depression. They're both made from a horizontal line, however angle of elevation is above the horizontal line, while angle of depression is below it. All right, so we'll be giving you guys some practice work over this material here very shortly. So if you have any questions about anything, by all means, let me know. But until next time, guys, thanks for watching and take care.